Okay guys, today's video is going to be a firmware upgrade and PM FCC checkout on a BK Radio KNG M-150 mobile, and I'm just going to go ahead and get right into it. We'll start off with the firmware upgrade on both the head and the radio itself, and then we'll go into the PM checkout after that. I have on my laptop brought up the Lightning Light 2.1.10, and we're going to be putting the S version firmware into the head and also into the radio itself. So we start off with the radios powered down, and we're going to do the control head first. So we're going to go ahead and plug in our USB cable here, and we're going to take our microphone push-to-talk, and with the push-to-talk engaged, we're going to go ahead and power up the head, hold it in, and we hear the little kerchunk of the USB, and I get the blue flashing light on my head, and I also see in my Lightning Light the correct control head come up here. So I'm going to just go over here and I'm going to go start, and it's going to download and install the new firmware, and this goes pretty quick, so it's not a whole lot of delay, and then we'll switch over and do the radio itself here, and there it is, and it's all done and scooting back up, and that's all good. So we'll go ahead and unplug, and we'll shut the radio off, change our microphone over to the main radio so that we can put it into flash mode. Once again, we're going to take our USB cable, we're going to take our microphone, push-to-talk engaged, power it up. We hear the USB chirp, and we see the flashing blue light here. We get a good mobile come up here, so we're going to start. And now it's going to dump the new firmware into the radio itself. And like I said, this is pretty painless, and just a good way to start your PM process, especially if you're doing a whole fleet of them here. And there you go, it's all done, and we're going to come out of that mode there. Alright, we'll go ahead and turn it off, and then we'll plug my USB cable, and I want to relocate my microphone here. Okay, so let me get a chance to get this out of the way and reset up for the checkout, and we'll be right back. Okay, we're back. Let's get right into it here. We're going to start with checking the receiver out, and we're going to be using the 12 dB Synad as our measurement tool. We have our speaker audio coming out of the main radio here. Since we have two speaker jacks, it's convenient, and I have it going through a 1-to-1 isolation transformer into my Synad input on my service monitor here, and we're going to be using the 60% maximum deviation, which in our case is 1.5 kilohertz, and it's a 1K test tone, and we're going to be relying on our bar graph up here to see our level. So I went ahead and got it all set up, and we're on frequency, and we're going to go ahead and crank it up here, and I'll show you. Now we're looking up here at our graph, and we're going to adjust our level until we get around 12. Come down here, something like that. So we would record that level down there. That's 0.28. Might be a little bit hot there, so say 0.25. And this isn't critical rocket science or anything. These levels are not super critical. If you're off, a couple dB here or there, it's not worth sending in to get fixed, in other words. But anyway, there we are there. We got 12 dB SINET there. And I'm going to go ahead and change over to 192, which is, so the channel I was just on is 151, which is the lower end. 192 happens to be 159, so we're looking at the upper end. So I'm testing the extremes of our receive window here. So I just want to make sure that I got good receive on both the high frequencies and the low frequencies. And you see there that we got a good level. And come down here and crank it up. We max out here. You max out of like 13, 14 dB, whatever it is. And here's our here's back to normal. Now I wanted to show you something while we're here in this screen, so that you can see for yourself, and that is the you should check the max squelch level. So we're going to go enter and we get into the squelch, and on the BKs here, oops, let me go. The all the way to the far left is max squelch. So this takes the strongest signal in order to open up the receiver. So we're going to sneak up on this and see how what the signal is to get in, and then I'll show you the hysteresis curve after it opens up here. So there we are. We opened up at minus 120, and I will go over here. And what the hysteresis is that once you trip it, it'll allow you to go down a level for a little bit, just so it's not so picky, before it'll kick back in again. And there's, you see, we got 1.5 dB down before it kicked back in again. So let me go back down. I'll go back up. I'll sneak up on it again. Okay, we got it there. Now I'm going to come back, see how far it'll let me. I was at 120.4. It's keeping it. And there. So about 1.5 dB, or I should say, yeah, about 1.5 dB of trip room. So that's what the hysteresis curve is. It's a little bit of leeway it gives you once it opens up. But anyway, that's a test for receive, and there's not a whole lot more than that. Make sure your volume's good and all that good stuff. So let's go ahead and move on to the transmit side. So let me come up here and go back to monitor. All right, and we're on 192. So that's the once again, that's a high transmit 159. And what we're going to be looking for is we're going to be looking for our power, our frequency error, and our deviation. Now I have my oscilloscope hooked up here to look at the DMOD audio, just to save it the source monitor from having the screen wasted to show that. And you see it a lot better on the oscilloscope. You'll see what I'm saying. So we start off. We'll just key it up. We can get a deviation reading on our PL. 350, 300. That's good. And we're going to be looking at our power, 109. Frequency error. It's almost right on the money. And if you look over here at the, like I said, on my oscilloscope, I'll do a full deviation, and you can see I got it set to where it pretty much takes the whole screen when I do. And this is a really good thing, especially when you're doing fleet PMs and stuff. You can just look and get a lot of information just from what you're seeing here, because if there's something off, if it's distorted, if there's bad PL, bad audio, you'll see it right away. There will be no mistaking it. So here we go, 4, 1, 2, 3, 4. Make sure you get a nice voice. Sounds good. 4, 1, 2, 3, 4. And you can see how I can get the full screen there when I see it. So once again, I got power, frequency error, my deviation. Let me go back down to 191 and change that. And the presets are extremely handy. Like I have 191 for one and 192 for my number 2 preset, so I can just go back and forth. And so I'm just going to double check and make sure I got good power there on channel 191 as well. Testing 1, 2, 3, 4, 1, 2, 3, 4, 4. Now in the analog radio setup we have here, there's really nothing to adjust. All the adjustments are done through other means, but we can't actually adjust any of these. So any of these that you see largely off, the radio will have to be sent in for repair. So, anyway, this is the basics of what you're looking for with a transmit. Now you can come over here and I would say a good idea is to come over to Spectrum Analyzer and let me get the dispersion a lot higher than that. And what you want to look for is you just want a nice single carrier. You don't want to see any kind of picket fencing like that or anything like it. Let me put it on 10 megahertz. Do a nice broad, and see it there. And so it doesn't like that. Get out of there. Not the biggest fan of the Motorola Spectrum Analyzer. They didn't do a very good job in this particular model. But anyway, yeah, you can, like I said, just have a look. Just make sure you're not spurring up across the spectrum there. And that pretty much takes care of your bench analysis of your radio. All the basics that you're looking for, your power, deviation, and all that good stuff. And now we can go ahead and shift gears and go and pretend like we're in the mobile now. And let me show you how you're going to do your antenna checkouts and your watt meter checks for it. So we got the radio back in the vehicle. Now we're going to come along and we're going to plug our antenna in. And one of the first things that we're going to go, check is we're going to come up to our, and I got a mag mount here to give you the visual, but we're going to go ahead and unscrew our antenna, do a nice visual inspection, clean up our NMO connector here, and make sure that's looking good. And before we do any watt meter checks on the radio, what you want to do is you want to get this is an NMO adapter. So you want to take your NMO adapter and screw it on to where your antenna is. And then I want you to come out and you're going to need to get a watt meter with a dummy load. Okay, so we're going to come out here and we're going to put the watt meter with the dummy load on our now NMO mount. And we're going to go to our radio and key it up, and we're going to measure how much power that we're getting actually at the NMO mount, and we're going to want to record that down. So we were getting 109 out of the straight out of the back of the radio. Now let's look at where we're got after we go through about 15 feet of RG58 to our little mag mount here. So I'm keying it up, and we're getting about 75, 80 watts there. And and you think, wow, that's 20 watts down, and that's about right. That's about what you would expect for the loss of of going through that much coax. And it's actually very forgiving at VHF. If this was 800 megahertz, you would have a lot less power making it to the antenna connector here. But anyway, this is a fantastic check to make sure there's nothing wrong with your coax cable going all the way back. If there was something wrong with it, you would see a big decrease in power here. Then you could take your watt meter, go back to the radio itself, and do a back and forth to confirm that, yeah, I got something wrong. And it'd probably be something obviously visual, something broken, something not right, something busted. But anyway, so this is your initial step, and before you actually do the watt meter checks itself. So after you do this, you go ahead and put your antenna back on, take your watt meter back to the radio, and now you're going to do your forward and reflected power measurements on both 191 and 192, and you're going to record those down, and that's going to give you your VSWR on the two ends that you have to cover. So as you need to be compliant in between those, and that way, and when you get the your measurements, then you can do your calculations if you need to do any for VSWR or anything like that. But the bottom line is to just look for the big ones. If there's something that's slightly off, you got 4 watts reflected here and 5 watts on this other one, it's not something to waste a lot of time on and to worry about. You have these various little fluctuations. Rarely can you get a really extremely cherry spot with your antenna mount. There's generally some piece of metal fairly close to it that's going to aggravate it a little bit and send it slide off. So just try and stick to the main power getting radiated out. Now the last thing I wanted to show you while we're here, and it's so easy to do, is I wanted to show you how to do an effective sensitivity test. And what that's talking about is that if there is noise in the vehicle, or if you're at a site, if this is your repeater or your base, and you suspect that there is just a lot of interference around causing you troubles, this is the test that you do to figure out, well, how much interference is there around? What level of noise do I have to overcome before my receiver starts working well? So to do this particular test, what we're going to need to do is we're going to need to take our antenna off the radio, and we're going to need to use an ISO-T, and this is an adjustable one here. You can make your own by just taking a T adapter and taking out the center pin on the middle branch there. Lots of different ways you can look that up, but we're going to use our ISO-T to sneak in an RF signal, and we're going to see how much difference, how much more signal it takes to sneak in when the thing is on the antenna as opposed to a dummy load. So I'm going to come in here and get my ISO-T connected. And because that ISO-T has got an air gap to overcome to get in line with the radio antenna, you have to put in a lot more signal than you normally would. So on this particular case, on my generator over here, I'm going to switch back to I'm going to switch over here to from RFIO to, oh, and I hope it's going to generate mode first. So we're going to generate. Let's turn that down. You don't need to hear that. And we're going to go generate there. All right, and so I have my ISO-T in line with my antenna. Our reference point is going to be when the antenna is off and there's a dummy load screwed on instead of the antenna. So this will be our baseline measurement. So let me come over here to our generate, and let me crank it up here until I can, well, it helps be on the right channel. There we go. So what I want to do is I'm looking over here at my synad meter, and I'm going to adjust for 12 dB synad. Like I say, this isn't terrible rocket science here. Somewhere around there. I'll call it 31 microvolts. And I would like to, if I can, and I'm going to switch to dBm on this one because it's going to help you show the relative difference. So we have -77 dBm for our reference with the dummy load on our antenna. So we're going to go ahead and come off the dummy load, and what this is going to measure is how much interference from all the lights and electronic equipment inside the office here is generating. So you can see when I put that antenna on, it squelched up because the noise went up. So now we're going to come up back over here to our level, and we're going to adjust until we're back to 12 dB. So we're at we would start at -77, and we'll call it somewhere in there, close enough. 55. All right. So what's the difference in there? 22 dB of descents, of sight descents. So that's showing you that it's not an incredibly noisy site. It's not dead quiet either. And of course, depending on if this was a real radio site, this amount of descents could go up and down all day long depending on which transmitters at the site were transmitting at the time. There could be a particular combination of transmitters where when these two transmitters transmit at the same time, it absolutely wipes you out. Otherwise, there's hardly any site descents at all. So site descents is kind of a weird thing. Well, what you can do and what they've been known to do is you can take something like this and actually hook it up to a 24-hour graph, you know, the paper graphs like they do earthquakes and stuff, just to see if you have some kind of, like, at certain times a day where the noise floor goes up or down. But anyway, that's the effective sensitivity test. If you do have a situation like that to where you're actually getting something really noisy, it's best to go over to your receive mode and go to your spectrum analyzer and use an antenna to sniff around and find out and actually look on the input frequency of your receiver and see what you see out there. Is there some kind of crazy signals out there? So if I come over and hook up my antenna now to let's have a look. And yeah, not too bad. You know, not an incredible amount of stuff out there, but anyway, that's it. That's the effective sensitivity test, and that pretty much concludes the basic tests that you would do. I wouldn't do the effective sensitivity test on every radio, just ones that you suspect have noise problems. But there you go. That concludes it, and hopefully that helps you guys out.